Okay, today we're looking at inequalities in triangles. And the first question is, can we form a triangle with any combination of 3 side lengths? So if you look at these triangles, which of them could you create a triangle with? Well, only this one, a 3, 4, and a 6. The 2 and the 3 is not long enough to close up that triangle. You're going to have a gap. Whereas also this one, we have 3, 3. It actually equals the side length 6. So once again, it won't be long enough to create a triangle. You have that gap. So this demonstrates that there is a special relationship between the side lengths of a triangle. And this is the triangle inequality written formally. The sum of the lengths of any 2 sides of a triangle has to be greater than the length of the third side. So A plus B has to be greater than C. A plus C has to be greater than B, and B plus C has to be greater than A. So if we ask you a question, determine if the given side lengths will form a triangle, 7 feet, 5 feet, and 4 feet, we want you to justify it using this triangle inequality theorem. So you need to show that all 3 of those inequalities hold true. If one of them doesn't, then it will not form a triangle. So you would want to show something like this. 7 plus 5, yes, it's greater than 4. 7 plus 4 is greater than 5. And 5 plus 4 is greater than 7. All 3 of them are true, and since all of them are true, you would say, yes, it's possible to form a triangle. Okay? Just remember to justify showing those steps. All right, and the next example, we have a 3, 6, and a 2. So once you go through checking all the side lengths, 3 plus 6 is greater than 2. 6 plus 2 is greater than 3. But 3 plus 2 is not greater than 6. So because one of the inequalities does not hold true by the triangle inequality theorem, it's impossible to form a triangle. Okay, so now you're going to try these 2. I would pause the video and check your answers. Okay, here are the answers. Hopefully you got those right. The first combination was possible, whereas the second wasn't because 3 plus 4 was not greater than 8. All right, the next idea we saw in class was how to determine the range for the third side of a triangle. So if I give you 2 side lengths of a triangle, the third side range will be between the difference of those 2 numbers and the sum of those 2 numbers. So for instance, what are all possible lengths for the third side for a triangle with 7 and 18 feet for 2 of the sides? So the third side will be between 18 minus 7 and 18 plus 7. So any number between 11 and 25, not including 11 and 25. Okay. All right, so go ahead and quickly try those. Pause the video. And the answers should be between 12 and 18 and 13 and 31. All right, and the last idea with inequalities in triangles will be ordering angles or sides within a triangle. So what you need to remember is the longest side is always going to be opposite the largest angle, and the shortest side is always going to be opposite the smallest angle. Okay. So if I have a triangle, DEF, we look at the smallest angle, which is 25. The side opposite angle F is DE, so DE is going to be the shortest side. D is the largest angle, so the side opposite DE, or D, is going to be EF. So EF would be the longest side. Okay. Therefore, we can order the side lengths from shortest to longest, DE, DF, EF. Okay. Typical type question. We can also ask you to order the angles from smallest to largest. So once again, you're going to look at the longest side and the shortest side. So the shortest side is JH. So the angle opposite JH, which is G, will be the smallest angle. The longest side is GH, so the biggest angle will be opposite, which is J. So we can order the angles smallest to largest, G, H, J. All right. So we have 2 problems for you to try. Once again, pause the video and we'll put the answers up shortly. All right, and here are the answers to those 2 problems. Hopefully you got those right.